Yes, sir, I can hear. Yeah.
Yeah. Okay, Matthew. So we will wait for others, okay, to join, and then we will start.
No problem, sir.
Fine. Hello, Nabal. Nabal, are you getting my voice?
Yes, sir.
Okay. We will wait for one other student for 2 minutes, then we will start. Okay, so today we'll start simple microscope. We will start simple microscope. So simple microscope is basically a convex lens, and when the object is placed within focus of the convex lens, then that convex lens behaves as a simple microscope. Simple microscope is very, very simple. It is nothing but just a convex lens. Simple microscope. convex lens. This is a convex lens, and hello, Nafisa. This is the principal axis, okay, and I'm placing one object in front of the lens like this. This is the object, okay, in front of the lens, and HO is the height of the object. So how the simple microscope works? So for that we will draw the ray diagram. First ray, parallel to the principal axis, okay, it will pass from the focus. Focus will be somewhere here, okay, and another ray from the object is passing from the optical center. Okay, this is suppose the optical center of the lens. It's like this. So both the rays, both the refracted rays, you can see here, are getting diverged, and diverging rays will never meet. So what we will do, we will just extend these rays in the backward direction, and where these rays will meet in the backward direction, that will be the image. Somewhere here these rays are meeting, okay. So this will be the, here at this point, means from here to here there will be the image. So this will be the image. This is the case when we place the object between the optical center and the focus in case of the convex lens. This is the same case. So here the object is placed, here the object is placed that you want to see, and when you will see like this in a simple microscope, when you will see and the object will be within focus, then of this object you will get a magnified image. You will get a magnified image. Magnified image you will get. If you will get the magnified image, then you will see the object properly. This is the height of the image. Okay. So from this side you will see this is your eyes. This is focus. Okay. Now object is placed here. This is the object. So we will mark the object distance. So this is object distance, because this is your eye will be nearer to this lens, na? So object distance I will represent with UE. You can represent with other. Hello, Nafisa.
Hello, sir.
Hello, how are you?
I'm fine, sir. How are you?
I'm good. Okay, so see, this is the simple microscope. Simple microscope is just very, very simple, because this is just a convex lens working when the object is placed within the focus. Within focus means between, object is placed between the optical center and the focus, between optical center and focus. Okay. Now there are few things here, few things. For example, suppose if this angle is beta, this angle is beta. If I want to find 10 beta for this triangle, from this triangle, na? This triangle, this is a triangle. See, this is a triangle, and from this triangle I want to find 10 beta. So 10 beta will be equal to this HO by UE, HO by UE, no problem. But what happens, na, this beta is very, very small because this object you are watching is very, very small. So beta is very small. So 10 beta, I told you many times, if beta is very, very small, if any angle is very, very small, so 10 of that angle can be written as that angle. Means 10 beta can be written as beta. So this 10 beta can be written as beta. So you can write beta is equal to HO by UE. And why I am calculating this beta, I will tell you later. Now there is one more term, alpha. So what is alpha? Alpha is the visual angle. Alpha is the visual angle formed by object. Visual angle formed by object kept at D. Visual angle formed by object kept at D. What is D? D is the least distance of the distinct vision. Means up to what minimum distance I can see clearly. Up to what minimum distance? For the normal human being, that distance is 25 centimeter. Okay. And if this is your eye, this angle is alpha. This is the height of object, and this distance is D. Okay, and this object is basically AB object. So from here you can find 10 alpha approximately equal to alpha, because alpha is also very small here, is equal to HO divided by D. HO divided by D. Okay. Now there is a term magnification for this microscope. Magnification. It will be represented by capital M. Magnification is beta by alpha. So magnification is equal to beta by alpha. So magnification is calculated by beta. Beta is this HO by UE, HO by UE, HO by UE. What is alpha? Alpha is HO by D. So the magnification will be D divided by HO. D divided by HO. So this will be the magnification of simple microscope. D is 25 centimeter basically. D is equal to least distance of least distance of distinct vision. And HO is the height of object. HO is the height of object. Okay. And what is this beta? This beta is basically the visual angle. This beta is basically the visual angle. Okay, so simple microscope, this is the working of the simple microscope, and if you want to find the magnification, then in this way you can calculate the magnification. So this is your eye, and the object is kept at a distance of d. D is the 25 centimeter, and this is the height of the object, and this is alpha. So for the microscope, na, magnification is given by visual angle formed by final image formed by final image divided by visual angle formed by object visual angle formed by object kept at D, and that is why I have written beta by alpha. Okay, basically this beta is the visual angle formed by the final image. Now you can see here, this is the final image, and this beta is the angle formed by the final image divided by the alpha. And what is alpha? Alpha is the visual angle when the object is placed at a distance of d, that is least distance of distinct vision, and that is 25 centimeter. Okay, write down. Done, Nafisa? Matthew?
Yes, sir.
Nabal? Okay.
Yes.
So remember, this is the magnification for the microscope. Visual angle found by the final image, visual angle found by the object kept at D. So see here, in this case, the image is formed at some distance here. So for the maximum magnification, the image should be formed at T. Image should form at D. D means the least distance of distinct vision. So for maximum magnification, case number 1. Case number 1, maximum magnification in case of the maximum magnification, final image should form at D. D is 25 centimeter, okay, for the normal human eye. Final image is formed at D. So if the final image is forming at D, means what is the object? Now see this figure. The object distance is UE, and object distance you will take negative because the incident light is in this direction and object distance is in this direction. So you will take UE as negative. You will take minus UE, and MS distance you will take D, and you will take this as minus D, because here also the image is forming on the left hand side. That is why you are taking the image as negative, image distance as negative, minus D. Now you can apply the formula. This formula you can apply. 1 upon F is equal to 1 upon V minus 1 upon U. So 1 upon F is equal to V, you have V, you have U, so you can calculate F. Okay, so you can write minus 1 upon D minus it will be 1 upon minus of UE is equal to, it will become minus 1 by D plus 1 upon UE. So from here you can calculate UE. So from this expression, what expression you have now? 1 upon F is equal to minus 1 upon D plus 1 upon UE. So from here you can get 1 upon UE is equal to 1 upon F plus 1 upon D. Okay. Now what is the magnification for the microscope? Simple microscope magnification, what you get? Remember this magnification, D by HO. D by HO. D is the least distance of distinct vision. HO is the height of the object. D by HO. So D by HO is the magnification. Not D by HO. D by UE it is. HO will be cancelled out from here. It will be D by UE. Sorry. D by UE. Okay, so now we have 1 upon UE. So here also there is 1 upon UE. So we can write D, and 1 upon UE can be written as 1 upon F plus 1 upon D. Now multiply D. So you will multiply D, you will get D by F plus D by D is 1. So 1 plus D by F you will get. So magnification you will get 1 plus D by F. What is D? 25 centimeter. F is the focal length of the lens. Okay, focal length of the lens. So this is the case when the magnification is maximum. Now case number second. Case number second. For normal adjustment or the relaxed eye. So when your eyes are relaxed and when the adjustment is just normal. So when our eyes are normal and in the relaxed condition, in that case the final image formed very far from our eyes. Okay, I will wait for 2 minutes or 1 minute. So for the normal adjustment or for the relaxed eye, the final image form at infinity. Okay. So for normal adjustment, relaxed eye. Final image should be at infinity. Should be at infinity. Now remember this means. Now we will calculate the magnification again. This time, see what is the object distance? Object is placed here. Object will be here, UE at a distance of UE. But the image is at infinity. So V is equal to infinity. So object distance will be same minus UE. But the V becomes infinity. So again we will apply 1 upon F length formula. 1 upon F is equal to 1 upon V minus 1 upon U. So 1 upon F, 1 upon V is 1 by infinity, minus 1 upon U is minus 1 upon UE. So it will become 1 upon UE only. So 1 upon UE, this time we have 1 upon F. 1 upon UE, this time we have 1 upon F. Now what is the formula for the magnification? So magnification is equal to D divided by UE. Okay. And 1 upon UE is 1 upon F. So magnification will become D by F. Now in this case, the magnification is less as compared to the previous case. So you can see here. In this case, it is 1 plus D by F. And here is only D by F. So in the normal adjustment, the magnification is less. And here is the case of the maximum magnification. So that is why the magnification is more. Okay, so write down. After this, we will discuss compound microscope. Okay, so compound microscope we will discuss now. So in compound microscope, there are two lenses. One is the objective lens and another is eye lens or eyepiece. Okay, two lenses are there. So we will discuss that. So this is the one lens and this is another lens. Objective lens is smaller. Okay, and eyepiece is larger. Means eyepiece lens is larger as compared to the objective lens. Okay, so this is the objective lens. Make it like this. So this is the objective lens and this is the eyepiece lens. So we'll discuss how this microscope will work. So I am taking one object and that object we want to see in the microscope. This is objective lens, this is eye lens, this is eyepiece lens. So suppose this is the object, okay, this is the object. And this is the objective lens. So this object is placed in front of the objective lens. So this objective lens will form the image of this object. So like this, the image will be formed. And somewhere here the hmm. sorry. So parallel, so it will pass from the focus, okay, and another ray from the object, from the optical center, it will pass straight somewhere here. Somewhere here the image will form. Okay. Here the image will form. So this, with respect to the objective lens, the image is formed here. For example, suppose this is the image. This is the image. This is the object that you want to see, and this is the image formed by the objective lens. Formed by the objective lens. Now what happens? Now what happens? This is the eyepiece lens. Now this image for this eyepiece lens will work as an object. Will work as an object. So image formation will take place by the eyepiece lens. Okay, basically what type of lens is this? This is objective lens. This is objective lens. And what is this? Eyepiece lens. Okay, and this have a small focal length, and this have large. This has the large focal length. Okay, this has large focal length. Okay, so now this object will work as a this image will formed by the objective lens will work as a object for the eyepiece. Now this eyepiece will form a bigger image of this virtual object, not the virtual object, this object somewhere. Okay, this is the image, but for this lens this will be object. So now we will draw the ray diagram again. First ray is like this, and it will pass from the focus. After this ray is parallel, na? So parallel ray whenever pass from the lens will pass from the focus. So it will pass from the focus like this. Okay, pass from the focus like this, and another ray from the object is passing from the optical center. Actually this lens is bigger, na? So focus will be far from the lens like this. So in the same way, this is the now it's fine. So now you can see this is the first ray from this, and this is the second ray from this object like this. And after refraction, both the rays are diverging rays. Both the rays are which rays? Diverging rays, and diverging rays will never meet. So what we will do, we will produce the diverging rays in the backward direction, and we will get the image. So produce the rays in the backward direction, and get the image. So somewhere here, I think, or far from, so you can just do like this. So somewhere here the image will form. Now you can see the bigger image, very bigger as compared to the object. See, in case of the compound microscope, how bigger the image formed. So this much bigger image will form. So final image is this. Okay. So final image is this. So this is the final image. Okay, write this as I dash. So this is the final image. And size of the image is very, very large. This is just, you can say, this is A dash and B dash. This is A dash and B dash. And this object is AB. Top point is A and bottom point is B. And this is A double dash, B double dash, A double dash, B double dash. A double dash, B double dash, B double dash.
So it's like the rays bending there, or is it just
These rays, na? You are talking about these rays.
no, those the rays at A?
Rays at A means
A,
these
yeah,
rays.
there, yeah. Are
Actually,
those
actually,
bending?
na. Oh, actually, na, these rays, na. You are talking about, there are two types of rays there. Actually, first type of rays are from refraction from this first type of rays are from this objective lens, coming from the objective lens and meeting here. And here you are getting the image. Okay. And second rays are emerging from this object, behaving, this is behaving as an object. Okay. So these are the second type of rays. Okay. And what was your question?
So like over there, they both the rays intersect, right? So from there, do they bend over there and then go to the eyepiece, or
Yeah,
like
actually, now what happens? You can say uh, your object is here in reality. Your object is here in reality, but rays are going like this. Means from this object, initially your object was here. See the whole phenomena, then you will understand what is there. Okay. Your object was here. This is the objective lens, and this objective lens is forming the image here. Okay. Because these rays are going, these rays are reflecting from this lens. Okay. These rays are refracting from this lens, and due to the refraction, the image is formed here. This is the image. Now this image is working as an object for this lens, eyepiece lens. Now these rays, okay, these and these rays are the rays from this, and these rays are the rays coming from the objective lens. Is it fine?
yes, sir.
Okay. So don't confuse, means go with the process only. Otherwise, there are many things in this. Okay, now the object is here. Okay. The object is initially, what is the original object? This was the original object. Okay. And this much bigger image you are getting. So now we will mark the distances. We will mark the distances. Okay. So object distance, what is the object distance? So this will be the object distance. Okay. This will be the object distance. Object distance of objective lens. The object is placed in front of the objective lens. Now where the image is formed with respect to the objective lens, means this objective lens is forming the image here of this object. So image distance for this objective lens will be this. From here to here, this will be the image distance, that will be V0. Why I'm writing V0? Because VO, this is for objective lens. Now for eye lens, this is behaving as object. This means this image is behaving as object. So for this eye lens, the object distance will be this, that I will represent it with UE, object distance for the eye lens. Now finally where the image is formed, and by which lens the image is forming? Finally the image is formed here. and by the eye lens or eyepiece lens the image is formed here. So now what will be the final image distance? Image distance is distance between the lens and this image. So finally the image distance will be from here to here. This distance will be the image distance. No, it's fine. It will be VE, image distance for the eye lens. Image distance for the eye lens, and you can mark the focus of the eye lens. So suppose here somewhere here will be the focus of the eye lens, because eyepiece lens is bigger than the objective lens, and here will be the another focus, means here focus will be here in this case. Understanding what is happening? Two lenses are there. One is objective lens. See the figure only. Don't think the rays are going here and there. Forgot that. Think there are two lenses. Think there are two lenses. Number one is objective lens, another is the eyepiece lens. Objective lens is smaller, eyepiece lens is larger. Smaller means the focal length of objective lens is small as compared to the eyepiece lens. So the firstly, what will happen? Firstly, the image will be formed by the objective lens. Okay. Firstly, the image of the object will be formed by the objective lens. Here, this is the image formed by this objective lens. Now, this image will work as an object for this lens. Now, this lens will form the image of this object somewhere else, means here. So, finally, what you are getting? This image you are getting, finally. Okay? Finally, this image you are getting. Now, after this, we will calculate the magnification. We will calculate the magnification. First, take the screenshot, then we will calculate the magnification. Okay. So, step by step, if you will do, then only you will understand. Now, we will calculate the magnification. So, magnification is the angle write down. Done, Matthew?
Yes, sir.
Okay. So now we'll calculate the magnification. Magnification is beta by alpha. Beta is the visual angle formed by the final image at the eye. Okay. And alpha is the visual angle formed by the object when the object is placed at D, capital D. So now we will try to calculate the magnification. Magnification M, and we know that what is the magnification? Magnification is alpha by beta. Okay, beta by alpha, sorry, magnification is beta by alpha, and beta is the visual angle subtended by the final image. Now, where is the final image? This is the final image, and the angle subtended by this image is this angle. So this angle will be beta. So we should mark this angle with some I think with this color will be fine. This angle will be beta. So what is beta? Beta is the visual angle formed by the subtended by the final image. So this is the final image. So this final image is subtending the angle of beta. Okay. Okay. So for that we will first calculate tan beta. First we will calculate tan beta. I told you many times that tan beta can be approximately equal to beta. Okay, tan beta can be written approximately equal to beta because this beta is very small. This beta is very small. So if you can write this as beta and see this triangle, this triangle. So if you want to write tan beta, then you can write this is a dash, this is a dash b dash divided by ue, because tan beta is perpendicular divided by base. So perpendicular is this height and this length is base. ue distance is base. So you can write tan beta is equal to a dash b dash divided by ue. So a dash b dash divided by ue. Okay. Now you can find out the magnification of the objective lens. Magnification of the objective lens. So magnification of the objective lens is given by the v by u. Okay, v by u. I told you that for a lens the magnification is v by u. So for the objective lens, this distance is v naught and this distance is in the direction of the light. So you will take this distance as positive distance. And this distance you will take as negative distance. Okay, because this is in the opposite direction of the light, incident light. So it will be v naught minus u naught. V naught minus u naught. So it will be v naught by u naught and there is one more formula for the magnification: height of the image divided by height of the object. So for this lens, the height of the image is this a dash b dash, and this is below principal axis, so it will be taken as negative. So you will write minus a dash b dash divided by ab. So this will be equal to minus a dash b dash divided by ab. A dash b dash divided by ab. Now from here you can calculate a dash b dash. So you have these two terms equal. Okay, this is v naught divided by minus u naught. This is equal to minus of a dash b dash divided by ab. This minus and minus will be cancelled out. So from here calculate a dash b dash. So a dash b dash, when you will calculate from here, so you will get v naught by u naught multiplied by ab. V naught by u naught multiplied by ab. So now find beta. So beta is a dash b dash by ue, And what is A dash B dash? V naught by U naught. Okay. And AB also. And here is UE. And what is AB? AB is height of object. This is height of object basically. So instead of AB, put HO. So beta is equal to V naught by U naught multiplied by AB is height of object divided by UE. So this is beta. Now alpha we can calculate very easily. Alpha will be same. H naught HO by D. So what is alpha? Alpha is like this. This is your I. Alpha is very simple to calculate alpha. This is height of object and this object is placed at a distance of D. Okay. And this is the I here. Now this angle is alpha. So if you will calculate tan alpha and this alpha is small, if this alpha is small, then you can write tan alpha as alpha. Tan alpha you can write approximately equal to alpha and that alpha will be equal to H naught by D. H naught by D. Now you have alpha, now you have beta, you can find the magnification. So magnification is equal to beta by alpha. So what is beta? Beta is this. V naught by U naught, H naught by UE, V naught by U naught multiplied by H naught by UE and divided by, this will be divided by H naught by D. Now H naught and H naught will be cancel out. This H naught and this H naught will be cancel out. So it will be magnification will be V naught by U naught multiplied by this D will be in the numerator divided by UE. Okay, so this will be the magnification. This will be the magnification for the compound microscope. V naught by U naught multiplied by D by UE. And what is this V naught by U naught? Magnification produced by the objective lens. And what is D by UE? You can see here D by UE. D by UE. Okay. D by UE is the magnification of the simple microscope. Okay. Or this lens, you can say eye lens, objective eyepiece lens, sorry. So you can write here magnification produced by the eye lens. So magnification of the compound microscope is compound microscope is equal to the magnification produced by the objective lens multiplied by the magnification produced by the eyepiece lens. If you have not taken the screenshot of this, then you can take distance if not marked at that time. Scroll down.
Yes, sir.
So this is the magnification of the compound microscope. So here also we will discuss two cases. First case, maximum magnification of the compound microscope, and for the normal as the adjustment for the compound microscope. Okay, if you are getting confused here, na, so I told you beta is the visual angle subtended by the final image. So this is the final image and this is the angle beta subtended. So first I calculated 10 beta, and why I have written 10 beta is approximately equal to beta, because this beta is small. So 10 beta can be written as 10. What is 10 beta? 10 beta can be written as is from this triangle. You can see 10 beta can be written as a dash b dash divided by this distance. Okay, this distance of the triangle. So a dash b dash divided by ue. Now after that I have calculated the magnification of the objective lens. Magnification of the objective lens, magnification of the lens is v by u. So v naught by minus u naught I have taken with sign. Okay. And there is one more formula for the magnification: height of the image divided by height of the object. So for this objective lens, the image is this and object is this. So height of the image is negative. So that is why I have taken this as negative. After that, I have equate both these equation, and from here I have calculated a dash b dash, and I have calculated a dash b dash, and this a dash b dash I have put here. Okay, so that I get beta. Finally I get beta. Okay, this beta I got, and after that alpha is simply the visual angle when the image is formed at D, object is placed at D, sorry. Okay, so now we will discuss the maximum magnification, case number 1. For the maximum magnification, I told you the image will formed at capital D, at a distance of capital D. Final image will formed at a distance of capital D. Final image at D. By eyepiece lens. So in this case, what will be the object distance for the eyepiece? Minus UE. Okay, minus UE, because this is UE for the eyepiece. This distance you will take negative. This is because this is in the opposite direction. You will measure the distance in the opposite direction of the incident light. So this will be negative, and final image is formed at minus D, means D. Okay, so finally the image is forming here, but this distance becomes D in case of the maximum magnification. Okay, and this is on the left side, so we will take D as minus D. And focal length will be positive because of the convex lens, plus FE. FE means focal length of the eyepiece. So now apply 1 upon F is equal to 1 upon V minus 1 upon U. So 1 upon F means 1 upon, we are applying this formula for the eyepiece. So we will take all the terms for eyepiece. So it will be FE is equal to, what is the image distance? It will be minus D. So it will be minus 1 by D. It will be minus of 1 upon minus of UE. From here we can calculate UE. So we'll get 1 upon UE, we will get Okay, this will become positive. So it will be 1 upon Fe plus 1 by D. 1 upon Fe plus 1 by D. So 1 upon UE is this. Now what is the magnification for the compound microscope? V naught by U naught multiplied by D upon UE. Okay, for the compound microscope, the magnification is V naught by U naught D upon UE. Okay, so V naught by U naught multiplied by D, and 1 upon UE can be written as 1 upon Fe plus 1 upon D. So finally, when you will multiply D here, so it will become D by Fe, and this will become 1 because D and D will be cancelled out. So it will become 1 plus D by Fe. So the magnification will become V naught by U naught 1 plus D by Fe. Okay, so this magnification you will have. Okay, this magnification you will have. Now for the normal adjustment, case number second. For normal adjustment, and in case of the normal adjustment, the image is formed at infinity. Okay, final image is formed at infinity. Means object distance will remain same, that will be minus UE. Image distance will be infinity. Focal length will be Fe. So now apply 1 upon F is equal to 1 upon V minus 1 upon U. Then calculate 1 upon, it will be 1 by Fe, 1 by V is 1 by infinity. It will be minus of minus 1 upon UE. So it will be 1 upon Fe is equal to 1 by infinity is 0. Okay. So this will be 0 minus minus plus, it will be 1 upon UE. So 1 upon UE is equal to 1 upon Fe. Now what is the magnification? So magnification for the compound microscope is V naught by U naught. Okay, V naught by U naught D by UE. So magnification M is equal to V naught by U naught, and this is D, and 1 by UE can be written as 1 by Fe also. So finally the magnification for the normal adjustment will be V naught by U naught D by Fe only. You can see here this magnification and this magnification. This is more because here is 1 plus D by Fe and here is only D by Fe. Okay. So this magnification is more as compared to this magnification. Oh, sorry. This magnification is more as compared to this magnification because this magnification is the maximum magnification. So there is a little bit calculation in this. Okay. Okay. So take the screenshot. Done? Matthew, Nabal, Nafisa.
Yes.
Yes, sir.
Yes, sir.
Okay, so here na, in this case, you have to think first what is happening, and then accordingly you have to draw the ray diagram. Why in the earlier classes we were studying the image formation by the concave and a convex lens? We have studied na image formation by the concave lens, convex lens. So because and now there is a application of that. We are using that here. All those concepts we are using here. And you can see, I told you in the beginning when the chapter was starting, sign convention will play a very important role.
Yes.
So now you can see again and again we are using sign convention. Again and again we are using sign conventions. So remember the sign convention. If you are measuring the distance in the direction of the incident light, then that distance will be considered as positive in optics. And I am not saying the distance can be positive or can be negative. Distance can never be negative, we all know. Distance is distance. 5 centimeter is 5 centimeter. We cannot say minus 5 centimeter distance. But sign convention means to make the study easy. Okay, that is why sign convention is chosen. And if sign convention is chosen means you also have to choose sign convention for the study, for make your study easy. And there are other things also that you have to focus on. Those things will be the basic concepts. Suppose if a ray of light is parallel to the principal axis in front of the convex lens, what will happen? You should know that. After refraction, it will pass from the focus. If I am saying if a ray of light is passing from the optical center, then what will happen? It will pass straight. And we are using this again and again. Here also I have used two images are means here there are two images formed. You can see one image is this and another image is this. For making the ray diagram, I used only those two concepts. You can see first ray is parallel. This is the object. First ray is parallel to the principal axis, will pass from the focus of this objective lens. I have not shown yet, but here is the focus. You should understand because I told you many times. If a ray of light is passing from the optical center, means this will be the optical center of the lens. You are in now you are in 12th class. So I think the basic I am considering that there should be the basic understanding, or I already told you things. Okay. So this was the image formation. Once again, I am explaining this diagram. So this was the object that you want to see in by using the compound microscope. Finally, what you are getting this image of this object. For this small object, you are getting this much large image. Means you are getting very large image of the object. Means more clearly you are getting the specifications of the object in the compound microscope. So what is the working? In microscope, in compound microscope, there are two lenses. One is objective lens, another is eyepiece lens. Objective lens has the small focal length. Eyepiece lens has the large focal length. First, the object is placed in front of the objective lens, and that objective lens produces a real and inverted image of that object. Okay, and that image, this is the image now. That image works as object for the eyepiece lens. This point should be noted. This point should be noted. This image will work as an object for eyepiece lens, and of this object, now you will say, sir, why you are saying this is object, this is the image? But I already told you this is the object for this lens. So for this object, this eyepiece lens will form the image, a bigger image here. And that is what you will see. Okay, Matthew, Nawal, Nafisa.
Yes, okay, sir.
Okay, so we will meet now the next class. Okay, this will be finished
Okay, sir.
definitely in the
Yes,
next
sir.
class. Okay.